Welcome to this explainer. Today, we're diving straight into the massive, invisible backbone of our modern world. From the light powering the screen you're looking at to the factories manufacturing literally everything we own, energy is the foundation of society. But right now, we're standing on the brink of an absolutely unprecedented transformation. We're going to unpack exactly how our global energy grid functions today, and more importantly, why it absolutely has to change. We've broken this whole thing down into 5 parts, starting with the global energy mix, the fossil fuel problem, the rise of renewable energy, the nuclear power alternative, and finally, upgrading our power grid. Let's get right into it.
All right, part 1, the global energy mix. Despite all the constant buzz around green energy, it's kind of wild to realize that a staggering 82.7% of our global energy supply still comes directly from fossil fuels, like coal, oil, and natural gas. Renewables are sitting at just 12.7%, and nuclear makes up the remaining 4.6%. This really shows us just how massive the mountain is that we need to climb to transition our energy systems.
Now, who's actually consuming all this juice? The reality might surprise you. The industrial sector absolutely dominates, eating up nearly 55% of all global energy use. Transportation comes in second at about 25%, and our homes, residential use, take up roughly 12%. The big takeaway here is that fixing our energy grid isn't just about driving different cars. It's about completely revamping how we manufacture and build our entire world.
Which leads us to part 2, the fossil fuel problem. So burning these fossil fuels doesn't just cause one isolated issue, it triggers a whole spectrum of problems. We've got carbon dioxide driving up global temperatures, sure, but we're also dealing with nitrogen oxides and hydrocarbons that create thick city smog, toxic carbon monoxide, sulfur dioxide, which literally causes acid rain, and particulate matter that directly harms our health. Think asthma and respiratory issues. Transitioning away from this stuff isn't just about environmental stability, it is an immediate public health necessity. That brings up a fascinating dilemma we hear about all the time. When we look at all that pollution, we naturally look for solutions, right? And electric vehicles are constantly touted as the ultimate zero-emission silver bullet. But are they actually zero-emission? Well, the reality is a bit more complicated. An electric car is only zero-emission if the electricity charging it is generated by emission-free resources. If you plug your brand new EV into a grid powered by a coal plant, that car is still indirectly responsible for those emissions. Every single kilowatt hour carries the footprint of how it was made. Upgrading our cars is really only half the puzzle. We absolutely have to upgrade the grid behind them.
Let's move on to part 3, the rise of renewable energy.
When we tackle energy problems, we really have 2 distinct complementary strategies. On one side, we have energy efficiency, basically conserving what we have by cutting energy use down to the absolute minimum without sacrificing our standard of living or industrial output. On the flip side, we have renewable energy, which is directly swapping out those polluting fossil fuels for sustainable sources like solar, wind, and hydro. Think of efficiency as buying us time and reducing the load, while renewables actually change the fundamental chemistry of how we get our power.
And here's a mind-bending fact for you. Most renewable energy is really just solar energy in disguise. Take a hydroelectric dam, for example. We think of it as water power, but that plant couldn't generate a single spark unless the sun evaporated the water, formed clouds, and created the rainfall that fills the reservoir in the first place. The sun is essentially the ultimate engine driving the Earth's entire natural power cycle.
And we're starting to physically see this transition happen right in our own neighborhoods. Green energy tech, like rooftop solar water collectors, are beginning to seamlessly integrate into our urban landscapes. They don't emit any pollutants or greenhouse gases, turning our everyday buildings from simple energy consumers into active energy harvesters. It's a real game changer. The growth trajectory of these technologies is absolutely wild. Back in 2000, U.S. renewables accounted for just 9% of electricity. Fast forward to 2017, and global solar capacity alone smashed past 400 gigawatts. Looking ahead to 2040, U.S. renewables are projected to double their 2000 levels to 18%, and by 2050, generation is expected to blow past 1,600 billion kilowatt hours. The momentum is undeniable, with capacity accelerating rapidly as costs steadily drop.
Let's shift gears to part 4, the nuclear power alternative.
Nuclear power essentially comes in 2 flavors. First, there's nuclear fission, splitting heavy atoms like uranium. This is the tech we use in today's power plants.
It generates massive power, but it does leave us with the complex headache of radioactive waste disposal. Then there's nuclear fusion, combining light atoms like hydrogen. This actually mimics the process powering our sun. It's incredibly clean, but overcoming the intense repulsive forces between nuclei requires temperatures of 100 million degrees. So as you can imagine, it's incredibly difficult to control and harness right now.
You might be wondering, why even bother with something as complicated as fission? Well, the answer is energy density. To put this into perspective, the complete fission of just 1 single kilogram of uranium-235 releases the exact same amount of heat as burning 3,000 tons of coal. No joke. Millions of times more energy than a chemical reaction from just a tiny fraction of the fuel. It is an incredibly potent tool in our zero-emission toolkit, provided we manage the waste responsibly.
Which brings us to our final piece of the puzzle, Part 5, upgrading the power grid.
Here's the massive hurdle we have to jump. The weather is notoriously unpredictable. Adding wind and solar into our grid introduces huge variables. The wind doesn't blow on command, and the sun definitely doesn't shine at night. Because of this, we urgently have to upgrade our conventional infrastructure into what's called a smart grid. We're talking about a highly flexible, intelligent electrical system that can dynamically adjust to handle the inconsistent hourly and seasonal swings of renewable power. But to make a smart grid actually work, we have to be able to store energy for a rainy day, literally, and that requires massive storage solutions. Sure, we have giant chemical batteries, kind of like the ones in your electronics, but scaled up for entire cities. But there's also an ingenious method called pumped storage. When we have extra wind or solar power, we physically pump water uphill into a huge reservoir. Later, when demand spikes and the sun goes down, we release that water back down through a turbine to make electricity. We are literally using mountains of water as giant physical batteries.
So we've looked at the staggering amount of energy we use, the real harm traditional fuels cause, and the brilliant solutions waiting for us in renewables and nuclear. But this leaves us with one critical overarching question to take away. As we innovate and rapidly scale up these clean energy sources, are we investing enough time and capital into the underlying wires and systems? Can we actually rebuild our aging, massive global grid fast enough to handle the inconsistent flow of nature before the impacts of our past emissions catch up with us? It's a race against time, folks, and upgrading our grid is the finish line.